Metallurgy is a domain of materials science and engineering that studies the physical and chemical behavior of metallic elements, their intermetallic compounds, and their mixtures. Metallurgy encompasses both the science and the technology of metals, including the production of metals and the engineering of metal components used in products for both consumers and manufacturers. Metallurgy is distinct from the craft of metalworking. Powder metallurgy, PM, is a term covering a wide range of ways in which materials or components are made from metal powders. PM processes are sometimes used to reduce or eliminate the need for subtractive processes in manufacturing, lowering material losses and reducing the cost of the final product. In this way, powder metallurgy can be used to make unique materials impossible to get from melting or forming in other ways. A very important product of this type is tungsten carbide. Tungsten carbide is used to cut and form other metals and is made from tungsten carbide particles bonded with cobalt. Tungsten carbide is the largest and most important use of tungsten, consuming about 50% of the world's supply. Other products include sintered filters, porous oil-impregnated bearings, electrical contacts, and diamond tools. Powder metallurgy techniques usually consist of the compression of a powder, and heating, sintering, it at a temperature below the melting point of the metal, to bind the particles together. Powder for the processes can be produced in a number of ways, including reducing metal compounds, electrolyzing metal-containing solutions, and mechanical crushing, as well as more complicated methods, including a variety of ways to fragment liquid metal into droplets, and condensation from metal vapor. The powder metallurgy press and sinter process generally consists of three basic steps: powder blending, die compaction, and sintering. Compaction of the powder in the die is generally performed at room temperature. Sintering is the process of binding a material together with heat without liquefying it. It is usually conducted at atmospheric pressure and under carefully controlled atmosphere composition. To obtain special properties or enhanced precision, secondary processing like coining or heat treatment often follows. The history of powder metallurgy and the art of metal and ceramic sintering are intimately related to each other. Sintering involves the production of a hard solid metal or ceramic piece from a starting powder. The ancient Incas made jewelry and other artifacts from precious metal powders, though mass manufacturing of PM products did not begin until the mid or late 19th century. In powder metallurgy, compaction is the process of applying pressure to metal or ceramic powders to form them into a desired shape. This step is crucial as it prepares the powder for subsequent sintering, where the particles bond together to create a solid component. Metal or ceramic powders are mixed and often combined with lubricants to aid in the compaction process. The powder mixture is then pressed into a die using hydraulic or mechanical presses. The pressure applied during compaction shapes the powder into the desired form. The resulting compact, called a green compact, is a partially formed, low-strength part that still has some porosity. The green compact is then heated to a specific temperature, causing the powder particles to bond together, forming a solid, dense component. In powder metallurgy, the compaction process is the shaping, deformation, and densification of a material via pressure from a tooling set. The compacting process involves compressing fine powders between rollers in a roll compactor. Once compacted, the material is typically broken down into smaller granules and screened to meet size specifications. This process improves material handling, storage, and usability across various industries. Compaction increases the shear strength of soils by adding friction from the interlocking of particles. Future settlement of soils is reduced by increasing the stiffness and eliminating voids, creating a densified soil. Compaction is a process of increasing soil density and removing air, usually by mechanical means. The size of the individual soil particles does not change, neither is water removed. Purposeful compaction is intended to improve the strength and stiffness of soil. Sintering in metallurgy is a heat treatment process used to consolidate powdered metal into a solid mass by heating it below its melting point, causing the particles to bond together. This process enhances the strength and integrity of the final product. Sintering is a thermal process where the powdered metal, often compacted into a desired shape, green part, is heated in a controlled atmosphere. The heat causes the metal particles to bond at the atomic level through diffusion, densifying the material and increasing its strength and integrity. The sintering temperature is below the melting point of the metal. The process effectively solidifies the compacted powder, transforming it into a more robust and durable material. Sintering of powder metals is a process in which particles under pressure chemically bond to themselves in order to form a coherent shape when exposed to a high temperature. If the temperature is above the melting point of a component in the powder metal part, the liquid of the melted particles fills the pores. This type of sintering is known as liquid state sintering. 6. A major challenge with sintering in general is knowing the effect of the process on the dimensions of the compact particles. This is especially difficult for tooling purposes in which specific dimensions may be needed. It is most common for the sintered part to shrink and become denser, but it can also expand or experience no net change. The main driving force for solid-state sintering is an excess of surface free energy. The process of solid-state sintering is complex and dependent on the material and furnace, temperature and gas conditions.